500 years ago, European families heated entire stone homes through brutal winters by lighting one fire for 90 minutes each morning. No furnace, no electricity, no monthly bill. That fire burned so clean, the exhaust left the chimney barely warmer than outside air. Nearly every joule of energy stayed inside the walls. The modern heating industry made sure you never heard about it. By the end of this video, you will discover why and how you can do it yourself. I'm Eddie, and welcome back to Construction Odyssey. Subscribe and hit the bell so you never miss what the heating industry hopes stays forgotten. Every ancient civilization that endured brutal winters independently arrived at the same conclusion. Stone holds heat. Force fire through enough stone, and the stone becomes the heater long after the fire goes out. The Romans proved it with the hypocaust. Korea proved it with the ondol. China proved it with the kang. Different continents, different centuries, identical physics. In Northern Europe, the principle evolved into engineered masonry heaters across Finland, Russia, Germany, Switzerland, Sweden, and Norway. The Russians called it the Russian stove. The Germans perfected the Kachelofen. These were not primitive fireplaces. They were thermal systems built by specialized tradesmen who passed their knowledge across generations. Then, between 1500 and 1800, Europe endured the Little Ice Age. In Sweden, the booming iron industry had devoured forests. Firewood was vanishing. The country faced a choice between warmth and total deforestation. King Adolf Frederick commissioned Carl Johan Cronstedt to solve the problem. Cronstedt partnered with General Fabian Reda, and in 1767 they created a system with 5 internal flues that changed everything. A standard open fireplace loses 90% of its heat up the chimney. Cronstedt forced hot gases to snake through chambers and channels inside the stove before reaching the chimney. The volatile compounds got burned completely. The heat soaked into the bricks. The bricks radiated steady warmth for 12 to 24 hours after the fire went out. He made the traditional stove almost 10 times more efficient. 19th century Sweden had the best heated houses in Europe. Then, during the early 20th century, central heating and electricity killed the tiled stove almost overnight. During the 1950s and 60s, most were torn down, not because they failed, because a new industry needed them gone. A masonry heater contradicts everything the modern heating industry sells. Instead of burning fuel slowly at low temperature, it burns a small load of wood intensely fast at extreme temperature. When wood ignites above 1,100 degrees Fahrenheit, it achieves nearly perfect combustion. Almost all fuel converts into heat energy with minimal smoke. Some designs burn far hotter, reaching 2,200 to 2,900 degrees Fahrenheit. The firebox is built entirely from refractory brick with no metal to limit the heat. Combustion happens in 3 phases. Primary combustion burns solid wood and releases volatile gases. Secondary combustion ignites those gases at higher temperatures. Tertiary combustion consumes remaining particles, delivering maximum efficiency and minimal waste. Compare that to a conventional wood stove operating between 400 and 600 degrees Fahrenheit. Incomplete combustion leads to creosote coating the flue and smoke pouring from the chimney. But combustion is only half the story. The true innovation is what happens after the fire goes out. A typical masonry heater weighs between 1,500 and 8,000 pounds. That mass acts like a thermal battery. It absorbs intense heat, then releases it slowly, over 12 to 24 hours. The internal channel system runs 20 to 25 feet, forcing hot gases to surrender their energy into the masonry before reaching the chimney. Fire brick holds 80% more heat than cast iron, while its thermal conductivity is 1/45th as much as steel. Heat enters the brick easily. It leaves reluctantly. Masonry heaters produce radiant heat. Like the sun, they warm solid objects directly: walls, furniture, people, not the air. The indoor environment stays fresh instead of parched. The exterior surface stays below 230 degrees, safe enough that families in Finland traditionally built sleeping platforms against the warm masonry. Heating efficiency reaches 85 to 95%. Customers who replaced conventional wood stoves with soapstone masonry heaters report cutting firewood use from 7 or 8 cords per year down to 1 or 2. Particulate emissions measure 2.9 grams per kilogram. EPA-certified stoves average 6 grams per kilogram. The masonry heater is 2 to 4 times cleaner than anything else burning wood. The United States Department of Energy confirmed it. Masonry heaters produce more heat and less pollution than any other wood or pellet burning appliance. A well-built one lasts for centuries. So why is there not a masonry heater in every cold climate home in North America? The answer has everything to do with money. The global HVAC market reached $258 billion in 2025. The average American homeowner spends roughly $2,000 every year on energy bills. Residential HVAC units last 15 to 20 years before replacement. Then families buy new ones. Americans spend over $10 billion annually on HVAC repair alone. Equipment that deteriorates, bills that recur, service contracts that compound. Now picture a masonry heater. One purchase. Burns free fuel, requires no electricity, no monthly payment, no mechanical systems to replace. Lasts centuries. One sale and then silence. Zero recurring revenue for anyone. The industry never had a single financial incentive to mention them. The regulatory system finished the job. Masonry heaters are not accepted in any building code in North America. The Environmental Protection Agency has never designed a certification program for them. Their testing protocol requires placing a stove on a weight scale. A masonry heater weighs 8,000 pounds. The cleanest wood-burning technology cannot get certified because the paperwork was designed for a sheet metal box. In Renaissance Germany, masonry heater builders belonged to a guild called the Hafnermeister, but very few crossed the Atlantic. America industrialized heating around mass production, identical furnaces, identical monthly bills. The masonry heater demanded a craftsman. The industry chose the catalog. But the science did not disappear. Since the 1990s, masonry heaters have been returning. Colorado and Washington now give them formal recognition. In Finland, Tuulikivi still manufactures soapstone masonry heaters at industrial scale. A custom installation runs $15,000 to $25,000. Factory models start around $8,000. But a masonry heater costs roughly the same as a high-end furnace, except it burns free fuel and requires no electricity. Over 20 years, it occupies an entirely different category of cost. Now here is the part the industry never wanted you to hear. You can build one yourself. There are two paths, a core kit or a full custom build from Firebrick. For most owner builders, the core kit is the smarter starting point. Companies like American Masonry Heaters manufacture complete refractory core kits that ship to your door. The firebox, the channel system, the bake oven, the doors, the damper hardware, the mortar. The pieces interlock, and a dedicated homeowner can assemble the core in roughly 2 days. Solid Rock Masonry in Duluth, Minnesota, offers hybrid systems using cast refractory slabs with Firebrick. They provide course-by-course photo instructions. Temp Cast in Toronto, Canada, has shipped modular core kits for decades, with proven performance across the Northeast. The build follows a fundamental sequence. Start with the foundation. Your finished heater will weigh 4,000 to 12,000 pounds. On a concrete slab, thicken the pour beneath the heater footprint. Over a basement, build an independent masonry foundation from a footing below the frost line. The footing should be 12 inches thick, extending 6 inches beyond each face. This is the one stage where many owner builders bring in a concrete contractor. Next, plan the chimney before you touch the core. Most heaters require an 8-inch round flue using Class A double-wall insulated pipe. The chimney must run at least 17 linear feet from heater to cap. It must terminate 3 feet above the roof line and 2 feet above anything within 10 feet. Keep it inside the conditioned envelope. Interior chimneys stay warm. Warm chimneys draw well. Now assemble the core. The first course must be perfectly level. Every course above inherits whatever error you introduce at the base. Apply refractory mortar between courses. Follow the manufacturer sequence without improvisation. Each channel, each chamber, each turn exists for a calculated reason. Changing the geometry changes the physics. After the core comes the facing. Brick is the most common. Soapstone is the most thermally efficient. Natural stone is the most dramatic. One critical rule: The facing must be independent from the core. An expansion joint separates the two layers because the core expands and contracts with every heating cycle. Bond them together, and thermal stress will crack it. Connect the chimney. Follow manufacturer clearances at every point. Maintain 2 inches from combustible framing for Class A pipe. Maintain 8 inches from the heater top to any combustible ceiling. These numbers come from ASTME 1602. Non-negotiable. Before your first real fire, cure the heater. Start with small kindling fires for 5 to 7 days, increasing the load gradually. Rapid steam expansion from trapped moisture can crack a brand new core. The daily routine resets everything you know about heating. Load the firebox once with about 20 pounds of wood in a crisscross pattern. Light the fire from the top down. The fire lasts 30 minutes to 2 hours. Once burning, close the door. Combustion gases travel through the channel system, transferring energy into thousands of pounds of masonry. When the fire is finished, close the damper. The masonry radiates heat for 12 to 24 hours, 1 firing per day in moderate weather, 2 in deep winter. The fuel matters enormously. Wood must be seasoned below 20% moisture. Hardwoods like beech, maple, birch, and oak are ideal. Oak needs 2 full years of seasoning. Buy a $10 moisture meter. If the reading is above 20%, that log is not ready. Maintenance is almost non-existent. No motors, no fans, no filters. An annual chimney cleaning is the primary task. Clean outdoors on the heater body let you inspect internal channels once a season. For those who want to build from scratch, the Masonry Heater Association of North America publishes construction guidelines. The association holds an annual meeting every April at Wild Acres Retreat in Little Switzerland, North Carolina, with hands-on workshops. The North House Folk School in Grand Marais, Minnesota, offers weekend building classes led by Eric Mosier, where you can build a complete core in 3 days. For new construction, design the heater into the center of the floor plan. Keep the space open so radiant warmth reaches every room. For retrofit, identify a location where the foundation can be reinforced and consult a structural engineer. Even when no fire burns, a masonry heater functions as thermal mass. Pair it with passive solar design, and the core charges itself on sunny winter days without a single match. European families 5 centuries ago solved a problem the modern heating industry pretends requires monthly payments and equipment replacements every 15 to 20 years. They stacked brick in the center of their homes. They lit 1 fire each morning and they stayed warm for an entire day. The Department of Energy confirmed it. The brick has not changed. The craft is still alive. The fire still works. Every furnace you have ever lived with was designed to need replacing. That was never a flaw. It was always the business model. The modern industry spent 100 years convincing you to buy something worse. But the brick is patient. The knowledge is returning. And now you know not just why it works, but exactly how to build one yourself. Subscribe to Construction Odyssey with Eddie, and please watch the next video appearing on your screen right now.